Quantum batteries could make it faster to charge a car than to fill a tank. Is holographic data storage the next step in advancing AI data centers? And NASA's hunt for extraterrestrials is coming into focus through optical masks. All your industry headlines are on Photonics Spectra Now.
Photonics Spectra Now is brought to you by MKS Newport, enabling technologies that transform our world. Visit newport.com to learn more.
This is Photonics Spectra Now, covering all the latest news and developments across the industry. I'm Joe Kaczynski, Senior Editor with Photonics Spectra. We begin with breaking news as NVIDIA makes yet another multi-billion-dollar investment in photonics. The latest agreement will connect Marvell technology to the NVIDIA AI Factory and AI RAN ecosystem. With this deal in place, the tech giant will give $2 billion to Marvell. This collaboration is about building on NVIDIA NVLink Fusion, a rack-scale AI infrastructure platform. NVLink allows customers to develop semi-custom AI infrastructure of their own using the NVIDIA ecosystem. For the project, Marvell will provide custom XPUs and compatible scale-up networking. You probably remember earlier this month, NVIDIA released details on separate $2 billion deals with Coherent and Lumentum. And this is all part of a larger trend. According to Forbes, in 2025, NVIDIA invested roughly $53 billion across 170 deals to advance its AI ecosystem. Vigo Photonics is expanding its global presence with the acquisition of assets from US-based Infrared Associates. The move builds on Vigo's presence in the States and enhances its offerings for the defense sector. Based out of Poland, Vigo Photonics is a manufacturer of epitaxial wafers and instruments for photonics and microelectronics. Adding Infrared Associates means gaining the Florida company's liquid nitrogen-cooled detectors. I got the chance to speak with Vigo Photonics CEO Adam Piotrowski to learn more about the impact this move is expected to have on the company. Here's what he had to say.
The US market was always important for us. We were competing with US companies on US soil. And there was an opportunity. Two companies that were doing kind of like complementary products, and the global politics came in with the tariffs, with the possibilities to block the trade between Europe and US. So we decided, let's take this opportunity. Let's go to create our own manufacturing capabilities in US.
You can listen to our complete conversation with Adam Piotrowski on the Photonics Media YouTube channel. Lumentum has announced plans to establish a 240,000 square foot manufacturing facility in Greensboro, North Carolina. The site will produce advanced indium phosphide-based optical devices like continuous wave and ultra-high power lasers. These devices are crucial in the development of AI data centers. Lumentum acquired the facility from chipmaker Qorvo. Along with gaining that facility, the existing workforce will also be added in the transfer. If you drive an electric vehicle, you probably already know that getting a full charge can take around 30 minutes. Well, thanks to new quantum batteries, charging your car could be faster than filling your tank. Covering R&D advancements, researchers in Australia have built a quantum battery that demonstrates super extensivity in a steady state. Not only could quantum batteries fast charge electric vehicles, they could also be used to charge devices remotely. Scientists from the Commonwealth Scientific and Industrial Research Organization, in collaboration with the Royal Melbourne Institute of Technology and the University of Melbourne, designed the platform for the battery as a multi-layered microcavity. Light is converted to an electric current through charge transport layers that are incorporated into the resonant microcavity. And the battery can be charged by either coherent or incoherent light source. Researchers from Fujian Normal University in China have developed a holographic data storage approach that stores and retrieves information in 3 dimensions. This process combines 3 properties of light, amplitude, phase, and polarization to get the job done. Allowing more data to be stored in the same space could have a big impact on advancing data centers. Now to the Netherlands, where teams from Twente and Canada's McMaster University are using tiny earthquakes to boost chip signals. Using a thin glass layer that creates these mini-quake surface acoustic waves, researchers can create ultra-precise radio signals on chips 200 times stronger than anything achieved before silicon nitride. Researchers say this platform could help connect an entire ecosystem of photonic technologies, adding that the most exciting applications might be ones we haven't even thought of yet. And NASA researchers may have just developed a new tool to find the next habitable planet and maybe even help us take a census of our neighboring solar systems. new types of optical vortex phase masks could enable the many orders of magnitude starlight suppression needed for future space observatories to pick out very faint habitable exoplanets from the far brighter glare of their stellar hosts. NASA's Habitable Worlds Observatory will be the first telescope designed specifically to search for signs of life on planets orbiting other stars. To complete its mission, HWO must be able to distinguish the very small bit of light coming from an exoplanet from the overwhelming glare of the very bright nearby host star. So in order to suppress the rings of an airy pattern, researchers use a coronagraph, of which the core component is an optical mask, designed to either selectively attenuate or delay the light distribution, making up the stellar image. Now, if you think I could sum up NASA's search for extraterrestrial life in just 40 seconds, you'd be wrong. Go to Photonics.com for the complete story and for our in-depth reporting on all the biggest headlines from our industry. And be sure to subscribe to the Photonics Media YouTube channel for all the latest from Photonics Spectra Now and from the award-winning All Things Photonics podcast. I'm Joe Kaczynski, and thanks for watching.